Rebecca Ode, and I'm the district resource teacher. We're going to be looking at first grade addition and subtraction strategies for this Math Dive-In 5. Before we begin, I want you to take a look at the tasks below. Go ahead and pause the video, and as you solve the tasks, think about what strategies you would like students to use to efficiently add and subtract within 20. Also think about what tools students might use to build these strategies to efficiently add and subtract. Welcome back. Now let's take a look at the progression within the BEST standards. Here are the kindergarten standards that students have left kindergarten with the expectation of knowing before first grade. They would have added and subtracted within 0 to 10 with procedural reliability. They also found the number that makes 10 when given numbers 1 through 9. And lastly, they explained why addition and subtraction equations are true. Keep in mind this is for the BEST standards. Make sure you watch the Maths to BEST transition video found in the Year at a Glance to know what the changes are with this year's standards. Now let's take a look at first grade. By the end of first grade, students will need to add and subtract from 0 to 20 with procedural reliability. This unit, you'll also focus on applying properties of addition when adding 3 or more whole numbers, and they'll be determining and explaining if addition or subtraction equations are true or false within 20. We've previously in other units been doing that very first bullet for first grade, but now we're going to be adding on these 2 new skills as well. Moving forward in second grade, students will then be adding and subtracting whole numbers to 1,000 and determining addition and subtraction equations being true or false within 100. So we again are setting foundations for future grade levels. So let's look back at the task now. What strategies did you come up with that students or even you might have used to efficiently solve these problems? Were any of these strategies that you used? As adults, we use many of these strategies without even thinking about it. We wouldn't typically write down that we made a 10, but we use it as a mental strategy. For example, for number 2, 4 plus 3 plus 6. I wouldn't add on or count on or even decompose or compose numbers, but I would group 4 and 6 together to make 10, then add 3. 10 plus 3 is 13. So I know that 4 plus 3 plus 6 is 13. In the first grade, we're going to support students as they build strategies for addition and subtraction within 20 with procedural reliability. They need to build concrete models to make sense of these strategies that we use as adults efficiently. So far, they've counted on, counted back, composed and decomposed numbers. In this unit, they'll learn how to make a 10. A reckon rack and a 10 frame are tools that help students easily see how to make a group of 10 to add and subtract efficiently. Here's how you could use a 10 frame. The students would put 9 on the 10 frame and the 6 outside the 10 frame. They can then move to fill the 10 frame and make a 10. Now 9 plus 6 is easily seen as 10 plus 5, and I know that the answer is 15. Here's the strategy of making a 10 to subtract, which typically is a little bit harder for students and, if I'm being honest, also for us teachers. So here we have 13 minus 5. All 13 are put into the 10 frames, really a double 10 frame in this example. Then we're going to subtract 5. Instead of subtracting 5, I get rid of one 10 frame and make sure that there's a full 10 frame first. So I subtract 3. Now I know 5 is 3 and 2. So now I have 10 and I'm going to subtract 2 more, which I know is 8. So 13 minus 5 is the same as 10 minus 2. And we want to make sure that as students are building these efficient strategies, that they are heavily relying on modeling them with reckon racks or 10 frames. Now, another reason we want to teach this make a 10 strategy is because when they're adding 3 or more whole numbers, this is really going to help with efficiency. The purpose is for students to explore addition and think flexibly when it comes to adding 3 numbers together, such as rearranging addends, looking for doubles, making a 10. Although they do not need to know the names of the properties, They will begin to apply the commutative and associative properties of addition by rearranging numbers and grouping them to make a 10, for example, which allows them to more efficiently solve rather than, say, counting on. Take a look. If this was a problem that students were being asked to do, 6 plus 3 plus 4, some students, they might say 6, then add on 3, then add on 4. That is a strategy that students could use. But they could also fill a 10 frame, make a 10, and add on 10 plus 3. Notice that in this strategy, the student also added 6, then 4, then 3 by rearranging the numbers. A student might also say, I counted on to 9, then counted to 13. If I hear students saying this, what does that tell me about their thinking? Are they wrong? Absolutely not. That's an efficient strategy, but I want to see how can I get them to make a 10 or use more efficient strategies. A representational model of making a 10 would be very similar. Students can begin by drawing out all the numbers that are represented in the equation, circle numbers to make the 10, and then add on. Once students become more efficient at solving addition and subtraction problems within 20, they can begin to understand that the equal sign means same as. Instruction should include a variety of problem types where the sum or difference can be on either side of the equal sign. Students can explore this through use of concrete tools such as a pan balance and unit cubes. When they see that both sides of the pan balance are at the same height, they can see the values are equal. When the balance is lopsided, they can see it's not equal. Students transition from using concrete objects that represent equations to the use of math symbols. Encourage students to read the same as whenever they see the equal signs. So in this example, 7 is the same as 5 plus 2. Students are likely going to have some misconceptions. One misconception you might see is that when they are adding 3 different numbers or more, they might not realize that when the numbers are rearranged, they will have the same sum. If you see this, have students solve the equation both ways, where the numbers are in one order and then the numbers are in another order. Discuss what was the sum. Have them recognize that the sum can stay the same even when the numbers are rearranged. Another misconception students might have is that they may continue using other counting strategies and not make the connections to the make a 10 for addition and subtraction. If you see this, give students more instruction and practice with learning number pairs that equal 10 before beginning to work towards fluency. If students don't see the pairs that make 10, making a 10 is going to be a very difficult strategy for them to efficiently use. Have them use counters of different colors and write the equations to see that there are number pairs that will always make 10. Another misconception you might notice as they're working with adding 3 or more numbers is that they may only add 2 numbers instead of all 3 or 4 numbers. If you see this, continue to provide experiences working with 3 or more add-ins, using concrete models and drawings to represent each problem situation. If students have concrete models to represent each add-in in the sum, they're more likely to add them together. And lastly, as students begin working with equalities, they may have the misconception that the equal sign means the answer is coming or calls for the action of doing the mathematical operation. If you see this, continue to provide students with experience using a balance scale. They need to reinforce the concept that the equal sign means both sides of the equation represent the same amount. Have them put counters or bears or some sort of objects on the balance to concretely model the equality of the equation. As you model these equations, also practice having students say is the same as. They'll say it if they continue to hear you say it. So 12 equals 5 plus 7 is not how we want to read it for students. We want to continue saying with them, 12 is the same as 5 plus 7. Point to the equal sign in any equation that comes up and have students say, what do we say when we see the equal sign? Students should say, is the same as, so that they remember that that means that both sides of the equation must be the same. So in this unit, remember that we're helping build students' procedural reliability when adding and subtracting within 20. Although they may not have this reliability after this unit, we want them to continue these strategies to have it by the end of first grade. We support them by giving plenty of concrete opportunities to make sense of efficient strategies and allowing them to make connections to representational models and ultimately abstract models. Thanks again for joining me for this Math Dive in 5. We'll see you again on the next one.